some basic trig. Okay? So, we're going to start with drawing a right triangle. We're going to skip, what trigonometry means for trigonometry. We're going to just draw a right triangle. Okay, here's my right triangle. We're going to label the angles. I'm going to label mine A. I'm going to label my right angle B, C. And I am going to find the opposite, adjacent, and hypotenuse of C. Opposite means across from. So here's C. Across from C, it doesn't share any of the same sides as my angle, is my opposite. Adjacent means next to. Okay? This side down here is my adjacent. And across from my 90-degree angles, and it also shares a side, shares part of the side with the angle of C, is my hypotenuse. You did learn this last year in geometry. We are reviewing it today. Okay, there is no talking going on. All right, now I'm going to turn it over, and we're going to talk about all this. Okay, a trigonometric ratio is a ratio of the length of two sides of a right triangle. The three basic trigonometric ratios are sine, cosine, and tangent, which are abbreviated as SIN, COS, and TAN, respectively. The angle from your line of sight mixed with a line drawn horizontally is called the angle of elevation. So we're going to talk about the different trig ratios. If we are looking in this case at angle A, we've got opposite, adjacent, and hypotenuse. So the sine is the opposite over the hypotenuse, A over C, lowercase, because lowercase stands for sides, where capital stands for the angles. Then we're going to look at cosine. Okay? Cosine is the adjacent over the hypotenuse. Adjacent is the one that's right next to it. Then we're going to look at tangent. Tangent is the opposite over the adjacent. We have the little b, little a over little b. Okay? These are something that you will have to memorize. So there's a couple different ways to remember this. I like to think of it as SOHCAHTOA. Okay? Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Okay? Some ways to remember this SOHCAHTOA are some of her children are having trouble over algebra. Some old horse caught another horse taking oats away. Some old hippie caught another hippie tripping on apples. Okay? Right? You can come up with your own way to do this, whatever way you want to remember. Okay? All right. Now we're going to try some stuff with our calculator. This is important that you know how to put this in correctly. You need to know how to change this from degrees to radians, because today we're going to look at degrees, but starting tomorrow, we're going to look at radians. Okay, so if we could pull our calculators up in front of us. You don't want to get wrong on the quiz or test because you don't know how to put it in the calculator, okay? We're going to find the sine button. So we're going to find trig. Trig is right next to the number 7 on your calculator. So if you touch trig, a bunch of different options come up. You're going to choose sine in this case and put 10. It's right next to the number 7. Okay. Yep. And then put 10, push enter, and you should get 0.1736. We're going to round to 4 decimal places. Okay. If you got something different, you're going to have to change your calculator from radians to degrees, and we will need to change this back to radians eventually because that's what we're going to do for Algebra 2. It's different than geometry. And we can do that by, if you would go to your home screen, hit number 5 for settings, number 2 for document settings, right the second one, angles, and you can hit degrees or click on it and you can change it to radians. You want to say make default because if you just hit OK, it doesn't make it default for everything. And then you hit OK again. Okay. Please try B, cosine 30, and C, tan of 44 right now in your calculators. Those next two. All right, what did we get, guys? Cosine of 38? 0.7880. And what did we get for tan of 44? 0.9656. Okay. Any questions about how to do that? All right, let's move on to finding trig ratios for B. We're going to look at example 2 right here. All right, first thing we're going to do, guys, is we're going to circle the letter B, the angle. And now we're going to label all of the sides. What is 4 to B? Is it opposite, adjacent, or hypotenuse? What is 3 to B? Opposite, adjacent, or hypotenuse? And what is 5 to be? Opposite, adjacent, or hypotenuse? Okay. My students who didn't have geometry last year, you guys doing okay with this? Okay. So we're going to look at sine. Do we remember what sine is? Opposite over hypotenuse, correct. So that would just be 3 over 5. Do we remember what cosine is? Adjacent over hypotenuse. So that would be 4 over 5. Good. And tangent? Opposite over adjacent. And that would be 3 over 4, right? Should be review for most of you. Want to make sure we've got it. Okay, let's do some problems now. Next page. All right. We're going to do, we've got 4, 5, 6, 7, 8 examples, and we've got some stuff we've got to learn about or review about special right triangles. Okay? So let's first look at A. We want to find both x and y. So the first thing we're going to do is we're going to circle the angle, and then we're going to label. Yes. We've got 24 degrees. I'm going to zoom in a little bit, guys. What is y to 24 degrees? Opposite, adjacent, or hypotenuse? What is 8? Opposite, because it's the cross from it. And what is x? Adjacent. Okay, let's find x first. Okay, If we're dealing with x, we need one other side. What other side is a number, not a letter? Opposite. So if we're looking at opposite and adjacent, we're going to use which one? Sine, tangent, or cosine? Tangent. Tangent is opposite and adjacent. Sine is opposite and hypotenuse. So we're going to go tan of 24 equals opposite over adjacent. So tan of 24 equals 8 over x. Okay, I think of these all as cross multiplication. Okay, so I'm going to put tan 24 over 1. Okay, 1 times 8 is, that's on one side of the equal sign. X times tan of 24 is, I like to put the x first so I don't think I'm taking the tan of x as well. So x tan 24. Okay, how would I get x all by itself at this point? Is it minus, divide? Divide because it's being multiplied, right? So I'm going to divide both sides by the tan of 24. And I get x equals, put that in your calculator, 8 divided by tan of 24. What do we get, guys? Okay, so you literally put in the number 8, push the division sign, hit the trig button, scroll over to tan, type in 24. Did you get 17.968? It says, what does it say in the directions, though? It says round to the nearest 10. So again, we'd say approximately 18? Yes. Can you bring your calculator here so I can see what the issue is? So 8 divided by tan 24. You, I think, changed it. I'm going to make sure it's not in radians.
Oh, so you wanted it to be radians.
We're going to do it in radians later. Right now we're doing in degrees. First, we're going to remember how to do it in degrees, and then we'll do it in radians. Okay, next we're going to do find y. So if we're looking at y and 8, because that's the other one with my, that has a number instead of a letter. So how are we going to set this up, guys? We're going to do sine because we have opposite and hypotenuse. So the sine of 24 equals opposite over hypotenuse. And then we are going to cross multiply. So we get y sine 24 equals 8 because we times it by 1. Then we'll divide by the sine of 24. And we get y is approximately what? So remember we went around to the nearest 10th. And I get 19.7. Okay, let's try B. We found all 3 sides. We didn't need to for this one. Right, the adjacent side. Well, we found the adjacent side, but we would have had to have the opposite side missing. Okay, so now we're going to move on to the next problem, which is letter B. We're going to do the same thing. We've got 52, and what is y to 52? Adjacent. What is x to 52? Opposite. What is 15? Hypotenuse. Oh, I'm sorry. Nathan. Okay, so let's find x first. We've got opposite, and what other one has a number next to it? Hypotenuse. What's opposite in hypotenuse? Sine. So the sine of 52 equals opposite x over hypotenuse 15. We make a 1 underneath, and then we're cross multiplying again. X equals 15 sine of 52, which gives us what? 11.8. Yes?
I don't understand what you meant by it has a number next to it.
So, I am trying to find x. The only other side with a number next to it is the hypotenuse because the adjacent has a y. So I know if I'm trying to find opposite, I can't use adjacent because that won't help me solve because I'll have 2 letters and I just want 1. Okay? All right, so let's find y. How are we going to find y? What are we going to use? Because we have the adjacent and the hypotenuse, right? So we want cosine of 52 equals adjacent y over hypotenuse 15. And then we'll cross multiply 15 cosine 52 equals y. So y equals, or is approximately, because we'll round. What is it? 9.2? Yep. So now I want you guys to try C and D on your own. Please try C and D on your own. Okay. C and D. Right now. Good. Then you can do it. C and D. So pick up your pencil, put it on C, try C and D. So we are right here. Make sure you label the sides first, opposite, adjacent, hypotenuse. And decide what letter you're solving. Once you have it labeled, decide if it's sine, cosine, or tangent.
Trig.
Or I do for C?
Uh,
Label my sides first. What sides am I looking at?
X is opposite.
X is adjacent.
Yeah.
Mhm.
Yeah, X is adjacent.
Okay. But then
Y is opposite, and 7 is hypotenuse. Right, because here's 64, and we're not looking at the angle up here. We're looking at the one down at the bottom, so that's why it's adjacent. That's the most common mistake, is mixing up your adjacent and hypotenuse.
Really?
Mm-hmm.
Isn't the hypotenuse?
No, I mean the opposite and adjacent, excuse me. All right, so we are going to set this up. We've got cosine of 64 equals the adjacent x over the hypotenuse 7. We cross multiply and we get 7 cosine 64 equals x. So x is approximately what?
7. 3.1.
What is it?
3.1.
Okay.
Yeah, that's what I said.
Okay. And then we've got sine of 64 equals the opposite over the hypotenuse. We cross multiply. And what is y going to approximately be? Approximately 6.3. We agree? Everybody agrees? Yes or no?
Yes.
Okay. Let's move on to D. We have 30 degrees. This is my opposite. This is my adjacent. And this is my hypotenuse. Shh. If you have a question, please ask out loud for everybody, or keep quiet. All right. So we're going to do the sine of 30 equals the opposite x. Quiet, please. Over the hypotenuse 10. So we get 10 sine 30 equals x. And that means x equals 5.
5.
And then we did cosine of 30 equals the adjacent over the hypotenuse. So we get 10 cosine 30 equals y. So y equals
8 points.
8.7. Or 10 square root 3. But we'll talk about that in a minute. Put your phones down, please. Let's look at our word problem.
You're going in the back.
Okay, we ready? We're going to look at our word problem. A train is traveling up a slight grade with an angle of only 3 degrees. This is 3 degrees right here. After traveling 1 mile, what is the vertical change in feet? So, the vertical change is my opposite. The 1 is my adjacent. So what do I need? Sine, cosine, or tangent to figure this out?
You said 1 mile is what?
1 is my adjacent. X is my opposite.
You mean the big tangent?
So I'm going to go tan of 3 degrees equals opposite x over adjacent 1. I cross multiply. And then you just simply put the tan of 3 into your calculator. And what do we get, guys? We get 0.05 of a mile. Okay, let's look at the next word problem.
That's the answer.
Yeah. So they said what is the vertical change in distance? So it's only 1/4 of a mile is a change in distance. All right. Let's try to figure this one out. Less me, more you. Example 3, using trigonometric ratios, it has a lighthouse on it. At 2 p.m., the shadows of a lighthouse is 22 feet long, and the angle of elevation is 72 degrees. Find the height of the lighthouse at 4 p.m. The angle of elevation is at 40 degrees. Find the length of the shadow cast by the lighthouse. Then at 6 p.m., the length of the shadow will be longer or shorter than it was at 4 p.m. Please explain. Okay, so we want to know how tall the lighthouse is. Okay? If the shadow is 22 degrees and the angle of elevation, and we'll go back, what does it say the angle of elevation is? 72, but what is the angle of elevation? What does that mean? If we look at the very front, it says the angle of your line of sight with a line drawn horizontally is called the angle of elevation. So we're going to assume right here the angle of elevation is 72 degrees with the ground. Okay? So we've got the what? X. The height of the lighthouse is opposite, adjacent, or hypotenuse of X. And 22 would be opposite, adjacent, or hypotenuse with 72. Adjacent. And so what formula are we going to have to use? Sine, cosine, or tangent. Okay. So the tan of 72 equals the opposite x over the adjacent 22, and then we're going to cross multiply. Am I going too fast? 22 tan 72 equals x. So x equals 22 trig button tan 72 gives me 67.7 feet. Okay. At 4 p.m., the angle of elevation of the sun is 40 degrees. Find the length of the shadow cast by the lighthouse. So now we know the lighthouse is 67.7 feet, correct? We want to know how long the shadow is. And I'm saying now the angle of elevation is 40 degrees. How long is that shadow? What am I going to use? What is x? What is the shadow? Opposite, adjacent, or hypotenuse? Adjacent. What is 67? So I'm going to use which trig function? So I'm going to say tan of 40 equals the opposite, 67.7, over the adjacent x. And I'm going to cross multiply. X tan 40 equals 67.7. Then I'm going to do what next to get x all by itself? Divide by tan 40. So x is approximately 67.7 divided by the tan of 40 gives us 80.7. That is a very long shadow. So which is it longer at? When do you think it'll be longer? Do you think it'll be longer at 6 p.m. or 4 p.m.? Right, because the angle of elevation will change, right? Okay. So we've got two more things, and then you guys can work on your homework. Are you ready? We're going to talk about special right triangles. Yeah. We're going to talk about special right triangles, 45, 45, 90, and 30, 60, 90. Okay. A 45, 45, 90 triangle means that it's isosceles. Two of the sides are the same. So both of these are x. And then my hypotenuse is going to be x square root 2 is big, just like we talked about with the warm-up today. Please make sure your phones are down and you're writing this down. Okay? 30, 60, 90 triangle. 30, 60, and 90. For a 30, 60, 90 triangle, the side across from 30 degrees is x. The side across from 60 degrees is that small side times square root 3. And the side across from the 90-degree angle, the hypotenuse, is 2x. It's twice as big. 60, 90 triangle. Joe, you're going to want to write this down for him. Okay. All right, so we're going to do an example. We're going to do a 30, 60, 90 triangle first because we did a 45, 45, 90 for the warm-up. Okay? So, if we have an equilateral triangle, what do equilateral triangles mean? What is special about them? All sides are the same, and importantly, all angles are 60 degrees. I'm going to do it right now. Okay. The altitude is from the top to the bottom, like that. Okay? So what did I do? I just made two triangles. Do you see that I just made this 90 degrees with the altitude to the bottom? And instead of 60 degrees at the top, it's now 30 degrees. Now it tells me that the side lengths of the equilateral triangle are 20 inches. We agree? Okay? So, what would it be across from 30 degrees? So, if we know that the hypotenuse is 20, let's look at our triangle up here. If the hypotenuse is 20, what's across from 30 degrees? 10. Now, what's across from 60 degrees? 10 square root 3. That's it. Okay, let's look at another one. We've got a square. What do we know about squares? All their sides are equal, right? All their angles add up to 90 degrees. All their angles add up to 360. Each angle is 90 degrees. Derek, can you come back and sit in your seat, please, and stay there? And stop packing up your stuff right now because we've got plenty of time left. Why don't you come sit here and write this down? If you need another pencil, I've got one right here. Okay, so if I've got a square whose perimeter is 20 meters, what are the lengths of all of my sides? What are the lengths of all my sides? 5, right? Now, if I wanted to find the length of the diagonal, what would those 90 degrees change to?
5 square root 2.
If I wanted to find, because that's not my question, thank you. If I wanted to find the angles, what would they be? 90 degrees, we cut in half, it would be 45 and 45, correct? Okay. Now, we know from our drawing that if both of these are 5, the hypotenuse is 5 square root 2. The length of the sides times the square root of 2. Questions? Okay, your homework tonight is just trig functions, basic trig functions. You don't have to put anything in the calculator. And basic 30, 60, 90, and 45, 45, 90. So on the top, on one side of your special right triangles, it does give you those things again. That 45, 45, the hypotenuse is a square root 2 is big. It does give you on the 30, 60, 90 triangle that the smallest side times square root 3 is the middle side. And the smallest side times 2 is the hypotenuse. So you can find 1 through 12. And you can find all of these here, sine, cosine, and tangent for each one of these triangles depending on what angle it's talking about. Okay? So we're going to find out what did Miss Margarine think about her sister's husband. And on the back we're going to see in a 30, 60, 90 right triangle, the sides opposite the 30-degree angle is blank. Okay?
Are we going to be back?
So,
When I go.